Hello, guys. Good morning. Not sorry, good morning. Good evening. And can you hear me? All of you over here? Yep. So today our plan is really interesting. So I will share the idea with you what we are going to discuss today. I'm really sorry for this sudden uh, delay, but we will start as soon as possible. Yep. So very good. So let's start. Today what we are planning is the following: how to prepare for geometry. Can all of you see this screen, guys? Can all of you see the screen? So today we'll be discussing about the ways to prepare for geometry in Pre-RMO and IOQM, okay? Now, why just geometry? So we have decided that we will be doing it for each and every topic over here. Yeah, of course, it's helpful everyone who want to do geometry, okay? It's like for preparation purposes, for normal like purpose of anything. And after that, we will be doing one bonus real-time problem solving today based on the things that we have learned. It's exciting, guys. So let's start. So, what is there for us? The first idea is that for preparations, first thing we need is self preparation. How can, so what are the best friends? Who are the best friends who can help you self prepare? Books. Books are the best friend over here, right? So, we need books for that. So, what are the books? Let's see. For IOQM and Pre-RMO, we don't need really huge books. So I will suggest you two easy books for you guys. Let's see what books. Number one book is Pre-College Mathematics. Challenge and Thrills of Pre-College Mathematics. And it's really interesting, okay? The book is really lovely. The main idea is that the book, there is a section in the books which is called Geometric James, which I really love. So I think you will be enjoying that section. So let me share with you what you need to do in this book. So there are three parts I believe to do with for geometry. One is the Euclidean geometry, second is the trigonometry, the third is the coordinate geometry. So these three parts comprise of the entire geometry section. Okay. So these three parts comprise. Let's see what chapters you need to do for this book. In this book, you need to do chapters of geometry and straight lines. So understand that how do geometry started? How did geometry start? It starts with the axioms of geometry, the Euclidean axioms, and then we understand the properties of straight lines, like when straight lines happens, what are the parallel straight lines, and when two straight lines intersect each other, the angles between them. So understand what is a straight line. We understand what is an angle first of all, then straight line, and then angles. We understand the relationship between straight lines and angles. That is the vertically opposite angles and stuff like that. And then we go into the stuff where we use the straight lines to form triangles. So if you form triangles, there are angles and triangles in a like angles and straight lines in a triangle. So naturally asks, there comes two aspects. One is similarity and one is congruence. But let's do first congruence. So congruence, where there are three types of congruency: SSS congruency, SAS congruency, all these RHS congruency. Okay, and we understand also congruence in 3.2, and then parallel straight lines come up where we understand that this vertical, like opposite angles have some alternate angles, some is corresponding angles, alternate some, like the sum of the same side or corresponding angles 180-degree, the alternate angles are equal. So these things we really learn from the parallel straight line. So these are the basic things you must do. If you haven't started yet, you must follow this 3.1, 3.2, and 3.3 first. These are really easy, and do the back end exercises. Then where you're becoming also properties of triangles, you have triangle inequality, which is just triangle inequality is a different way of saying that what is a triangle. So can you tell me what is triangle inequality? It's a different way of saying that in a triangle, AB plus BA is AB plus BC is greater than AC. So it's a different way of saying that the shortest line between A and C is AC rather than any other line out there, any other curve out there. That is the beauty of triangle inequality. So we understand the basics of geometry in this, and then we move ahead to properties of triangles. This is advanced stuff where we learn about what incenters, centroids, orthocenters, circumcenter, every such beautiful aspect of triangles coming up. Okay, and then we learn about, also in parallel straight lines there are ideas about parallelograms and stuff like that, which is also important. So in the properties of triangles we learn about these beautiful ideas, medians, centroids, and stuff like center, incenter. Okay, we understand this, and we understand it through various results. They're concurrent and stuff like that. And then we understand similar triangles, and in the similar triangles we learn about midpoint theorems and applications of midpoint theorems. The applications of midpoint theorem requires us parallel straight lines ideas. Okay, and then we move ahead to congruence and collinearity. What is this? This is the most important point where we try to understand the conditions for when 3 points are collinear or 3 straight lines are concurrent. That is done by Sever's theorem or Menelau's theorem. So you learn this exciting stuff in properties of triangles till now. So all this time we have learned about triangles and properties of triangles and all this stuff over here. Now it's come time to go on to geometry. In geometry, what we do? In geometry, we learn about circles, the basics, the angle in the circle, the angle in the semicircle, the chords, the midpoint theorem and the chords, and how it's this book is Rajvardhan, this book is pre-college. Okay, this book is pre-college. So this book is best for IOQM. Okay, just best. I personally love this book. I have learned it myself from this book, Rajvardhan. So now, in this we understand about cyclic quadrilaterals, tangents, and we understand that beautiful result, alternate segment theorem in tangents. And then again we come back to triangles revisited. Why? In this chapter we connect circles and triangles to understand the incircle, circumcenter, and beautiful stuff like this. Very beautiful stuff like this. And then we move on to constructions, how we can do constructions, and then we move ahead to geometric gems, which are the most beautiful part of this book. So if you can follow all these things for Pre-RMO IOQM, I don't think you need 4.6, but you need to do all 3.21. You may be very good with 3.1 till 3.6 and 4.1 to 4.4. 4.5 and 4.6 maybe skipped, but to understand, get a flavor of entire geometry, you must do this first. This is the first book. Oh yeah, book hai. This book is actually pre-college book. This is really a good book. I love this book. Challenge and Thrill of Pre-College Mathematics by V. Krishnamurthy, C.R. Praneshwar. Okay. So this is a really good book. So this is just for Euclidean geometry, guys. Sure, I will tell you. So this book has really good problems. Sri Pranad Devakaranda. So this book has really good problems. Each end may about 30 to 40 problems are there as you are requiring. Each of these exercises may about 30 to 40 problems are there. So if you want problems, that's why I recommended this book. Okay, do this book. It's a really important book and really exciting book. It's a basic book and it goes to the higher level. So if you want to do this, we all suggest this book. Okay, so do this book. And then we come to coordinate geometry. For coordinate geometry, you can do this only straight lines and circles. So we'll understand how to apply coordinate geometry in this case also. Okay, that's also really important. That boils under coordinate geometry, and we can do also trigonometry from here. Trigonometry may you can do, yeah, there are more than 30 problems have been done. So trigonometry you can also do it from this book. It's really important to understand the trigonometry perspective, because you know what, you can solve problems with trigonometry and coordinate geometry, which is which is called bashing, because it's an algebraic manner. It's really easy to solve it. For example, Pythagoras theorem in Euclidean geometry is equivalent to sin square theta plus cos square theta equal to 1 in trigonometry. So there is a bijection, there is a connection between any problem you can solve in coordinate geometry can be solved in Euclidean geometry. Any problem that can be solved in Euclidean geometry can be solved in coordinate geometry. It just depends upon the complexity of the results needed. So make sure you know coordinate geometry and trigonometry, because in case you can't solve using Euclidean geometry, coordinate geometry and trigonometry will help you to solve the problem at least, even it's longer. So this is really important. So you must keep this in mind. So geometry doesn't mean Euclidean geometry. Geometry means Euclidean geometry, trigonometry, and coordinate geometry. So make sure you learn all these three. Okay. So Abhiram, you must also learn trigonometry. Okay. And then in the higher classes, you need to learn about complex numbers and how to use that. But that's not an important IOQM and the stuff. So you must be good with geometry, trigonometry, and coordinate geometry. Lovely. So let's understand the problem solving techniques now. So there are certain problem solving techniques that I know personally I have applied, so I want to share it with you while solving geometry. It's really important. Any questions till this point, guys? Any questions till this point? I would love to clear that. Any questions till this point? ISI B math, what do you mean, Anushka? Yeah, of course, Trigo is important, Sri Pranad. As I told, because it gives you enhanced arsenal in your problem solving skills, Sri Pranad. Okay, Trigo is really important. Trigo is really important. As I told, Pythagoras theorem in trigonometry in Euclidean geometry is same as sin squared theta plus cos squared theta is equal to 1. So right, any problem you can do with a right angle triangle, it can be done using trigonometry. Okay, very easily. You know, right? For example, cyclic quadrilateral ka sum of opposite sides is what? Cyclic quadrilateral sum of opposite sides is 180 degree. So opposite angle, sorry. So in trigonometry, you can, if you prove that if sine of theta is equal to sine of phi, or sine of two opposite sides must be equal to. So you can do this. You can use this property if you can. Like, you will understand why it's important. I will tell you. Okay. Yeah. First step. Rajvardhan Kadao. Yeah. So now advanced trigonometry book, Anju. Yeah, there is an advanced trigonometry book. It's a book by S.N. Loni. You can do that book for advanced trigonometry. Yep. Rajvardhan has told it. So I will tell you what are the tips for problem solving. Okay. Problem solving, problem solving Athanjali also good, but let's not get defocused. Let's come back to problem solving. So what do you think, guys? What is the first step for problem solving in geometry? What do you think? Hit your ideas in the comment section quickly. What do you think? What did you do? Tell in the comments, guys. What do you think is the best? The first strategy, draw figure. Any other ideas, guys? What do you do? Rajvardhan told draw figure. Others? Figure. Anju is also for Anju told figure. Anyone else? Any other ideas? Problems, what does it mean? I don't know. Good diagrams, exactly. Figure, good diagrams, figure, lovely. So figure is the first step, and you have got it correct. Always draw the figure. Draw diagrams. Geometry without diagram is like, you know, it's like eating without food. Just like, or drink, I don't know, like drinking without water is not a good idea because you can drink cold drinks. It's eating without food. Okay, so it's just like that. So you must draw diagrams. So now the next idea is that exactly draw figures with clean labeling. Now how does that help? Yeah, bird without wings. Now how does that help, guys? Can someone tell me in the comments? Hit your ideas in the comment section, guys. How does that help? How does the diagrams help? Why will we draw diagrams? Yes, why do we draw diagrams? Ramakrishna, angle chase is good idea, but only if you want to chase angles. Like if angle is a required idea, like if angle helps, maybe angle will not help. But yeah, that's a good idea. So the first is diagram drawing, but my idea is like, why we will draw diagrams? To get something, right? To what do you want to get? And this has happened to me a lot. We can visualize. Yeah, we can broaden the perspective to think better, to visualize. So what we can get visualizing? You're going close, guys. What you can get visualizing? The next idea is this, that you can conjecture from the pictures. It has happened to me thousands of times, guys. What has happened to me? This has happened to me that during solving, I have found out, but maybe, this angle seems to be 90 degree. Yeah, it's correct. See, you first draw diagrams. What happens from drawing diagrams? When you draw diagrams now, you get some ideas. Maybe this is a 90 degree, maybe this is, so let's see what ideas do you get. You can conjecture something from pictures. That is the angle 90 degree? So you can easily catch the things that your eyes can catch, guys. Is the angle 90 degree? Are the points collinear? Are the lines parallel? Is it a square? Is it a parallelogram? Now, why does this help, guys? Can you tell me why does this help? If you conjecture, this gives you a direction of approaching, guys. So if you ask, is the angle 90 degree? What you try to prove? Maybe you can try to prove that 3 points actually form a semicircle because the angle in a semicircle is 90 degree. If you want to prove it's a parallelogram, maybe you want to prove that, okay, we have to prove that these 2 lines are parallel. Maybe you want to prove that 3 points are collinear. Then you will think, okay, Let's prove it collinear using Menelau's theorem or like Seva's theorem or some other ways. So it gives you a direction of approach, guys. So only place where people get stuck, exactly, the only place people get stuck, in geometry is that they don't know how to proceed. In other cases, number theory, combinatorics, every other algebra, they can play around with the algebraic numbers and stuff like that. The algebra, the equations, they can play around, they can square it, they can cube it. But in case of geometry, you don't get a lead of how to approach the problem, guys, and how to do it. It's by first drawing the diagrams and you conjecture that okay, maybe this is happening, or maybe solving this problem, I have seen this type of problem before, and they have approached in this manner, let's approach in this manner. So this is the best idea. So this therefore it helps you. So you ask questions from here. There is the angle 90 degree. It seems like something I have done like this before, so let's proceed in that aspect. That is the lead you want to know. That is the lead it helps you to draw. The diagrams helps you. Okay, so let's move ahead to the next one. So first is diagram. Do you agree with me, guys, what I told? Who have solved problems in geometry, hit a yes if you're agreeing with me. Have you gained this idea? Like, have you faced this problem, and do you believe that this is really helps examples and it helps you really leading towards a solution? Hit a yes or no. If you have not, then I will have other hints for you. Okay, so that's good. Lovely, very good. This is the basic idea. Good, nice. So let's move ahead to the next one, guys. Step 2, use the back calculation law. So this is extremely useful, guys. I cannot emphasize on how much useful it is, guys. How does this help? For example, I will tell you one example. Very good, Anushka. You should do it. So I will tell you one example, guys. So when you use back calculation law, suppose in the back calculation law, it's asked you to prove that some complex equation, okay? By using back calculation and the given conditions, you can boil it down to just proving that two line segments are equal. Two lines are equal, or maybe the angle is 90 degree. So you understand what is the idea. Understanding the idea is this: you must be getting some conjecture. The idea is to get an idea what to do in the future, like of the problem, how to approach the problem. So it's like if you can get an idea by drawing the diagram, you can use back calculation law. So if you want to prove something, you can go to that proof and you can back calculate to get something that you want to get. For example, two lines are equal to this angle is equal to 45 degree maybe. Okay, so this will give you an idea about how to approach, okay, with all the results. So these are the two ways you can approach this problem, and you can understand where to proceed, because this is the only problem in geometry. It's a strategy in all problems, not just applying, but yeah, in strategy of all problems, this is a strategy in all problems. You're right, Rajvardhan. But the previous diagram drawing is only for geometry, but this is a strategy for all problems. You're right. So the next one, whatever observations you have, try to prove it by using the results that you know. Okay, this really depends upon your skills, but mostly I will tell you something. Take a good book, see lots of problems, okay, how they have solved it. So it will help you gain a lot of intuition about how they are approaching. I will tell you one story, guys. When I was in class 11, so till class 10, I was very bad in geometry. I was very, very, very bad in geometry because I didn't get the intuition. I didn't get the intuition. I will tell you how in class 11 I gave RMO till I gave RMO in class 9th. In 10th I didn't give RMO because of my boards exam. In 11th I gave an RMO. So I will tell you, in 9th when I started preparing, I didn't know about anything. I started learning. Geometry was my favorite. Number theory was my favorite, but I couldn't do geometry. I could do number theory. Okay. So geometry was my struggle, but I really want to be better at it. I have one of my friends in school who did brilliant geometry. So who can convert algebraic problems into geometric problems and solve in geometry and come back to algebra. He was so good in geometry. So, this is a very natural code that you must spend good amount of time with brilliant people out there to enhance your skill. That's why you all need teachers or good friends who can do geometry or group study or anything you want to learn. So what I did in class 11, entirely for the first 6 months, I sat with him, okay? And I saw him understand and solve geometry problems in front of me. So I sort of understood how he approaches a geometry problem. He didn't teach me, but I just observed. But you may tell that I don't have such friends. You don't have such friends, it's true, but you have books. So you go to take a book and see lots of problems, solve problems, so that you can get an intuition of how to approach. So that when you draw the diagram or when you understand this is I have to prove, you get an idea, okay, I have to approach this way because that person in that example has approached that way. I have learned it somehow. So this is really, really important, guys. And you know what? After that 6 months of sitting with that person, what happened with that friend? In 2-3 nights, I can solve almost 80% of the RMO problems. 80% of all the past RMO problems. You know, it means what? It means, yeah, exactly. His Rajiv Manoka book is really good. I have done that book myself. So make sure you do Rajiv Manoka's book for the geometry, for the problem solving, okay? For getting an idea of the problems, guys. How they are solved. It's a really good book, Anushka. Thanks for mentioning that. Rajiv Monaca book is really good. Okay. So next one, let's do that. So yeah, as I told, what questions you must ask? You must ask question like try to connect what you know, what to find. Is there any similarity of what you know and what you found? Okay, that is what I told. For example, this is something I really observed while solving my problem, guys. That suppose you want to find, you have to understand what does the result do, what does the theorem do. The theorem, one second, guys. Yeah, so the theorem is the theorems what you know. For example, the sine law. The sine law gives an idea about the relationship with a side and an angle, guys. The sine law gives an example. So when, yeah, geometry wizard is also good, but it's too advanced, so I don't prefer it. But yeah, pre-college is a very good book start. Sine law is a relationship between sides and angles. So when you are like when you are doing for sides and angles, when you think that okay, this is what you have to prove, you can use sine law. Cosine law gives a trigonometric idea of the connection between three sides. So if you think that we need to find a connection between three sides, maybe you have to use cosine law. Okay, so you can use a lot of these ideas before. Mainly, what one idea is really important is similarity. Similarity and congruence are really used in a pre-RMO and IOQM. Okay, so it's really important. Make sure RMO, pre-RMO, and IOQM. Make sure you understand this. Okay, make sure you can solve problems using similarity and congruence, because most of the proofs, if you see, they are based on similarity and congruence. Okay, so if you don't know a theorem, maybe you can derive the theorem in the exam hall. So these are the really important stuff. So make sure you're good with similarity, congruency, and circle. That is, you make sure you're good with the regions, the sections 3.2, 3.5, and 3.6. Okay, and this 4.1, 4.1, 4.1, 4.2, 4.3. Make sure you are good at this. Okay, you're confident in this. Good is a very okay. Last thing I told, that trigonometry helps a lot. Trigonometry helps you to solve, and coordinate helps you to solve problems in a different manner, guys. I will show you an example with this. So we'll solve problems now. So the bonus is now, let's do some problems now, okay? Let's do some problems based on what approaches we have done, and exactly we will do it in the same manner I have told, okay? So let me share my screen with you. Let me share my screen with you. Any questions, guys, till this point of time? Any questions? Any questions, guys? Let's do some problems. Okay, so let's do some problems. Problems के लिए let's do this. I will share a problem which I will do in two different ways. One using Euclidean geometry and one using normal things. So let's do it. You have to practice questions and know if you're right or wrong if the book has no solutions. So that's a very good question. The second last strategy, what did you tell Rajvardhan? Which strategy? How to practice questions and know if you're right or wrong and the book has no solutions? That's a good question. So Keval, the good thing is that you have to find the solutions of the book, and mostly you can use prove that questions to understand Keval, because prove that questions are really easy because you know what to prove, so it will enhance your, then you can go on to other questions. Observation is that when you have to, so it's like this. So the idea is that the second last strategy is this, that if you have some, if you suppose you, if you have to understand what is the relationship between the of the theorem is, if the theorem is about relationship between sides and angles, if the relationship between third side, relationship is between sides and angles, you understand which are the results there are between the sides and angles. So you connect with what you need to find and what are the theorems available in your hand, what are the arsenals available in your hand. But as I told, may not be remembering theorems. So what you do, so in that case you must make sure that you are good with similarity and congruency, because most of the theorems are proved using that. So make sure good with similarity, congruence, and circles. These are the things you must be very good with, so that you can prove that in the class itself, in the exam hall itself, sorry. Okay, so let's do some problems without further ado. Okay, let's do this problem. The problem is the following. Yep. 6 6, okay, lovely. So this is the problem, guys. I will share with you. This is a circle, sorry, square, what I'm telling, guys. And you take a circle with radius like this, and you take another circle with radius like this. I'm so sorry, maybe it's wrong, just give me a minute, let me check the problem. Yeah, it's right. Perfect. So what you do is that now you form a circle tangent to these three points. Let me draw that. Let's check this one. Oops. Okay. Let's say the radius is r. If this is 6 centimeter, this is 6 centimeter, what is r? That is the question. Okay, guys. It tells you that 6 cross 6 square is there, and this is the two corresponding like circles drawn, and a circle is drawn tangent to this. So what is the radius of this circle? So think about this. So we will be solving using two approaches now, and we'll see how they're connected to each other. Okay, and how one approach leads to the other, and how one other approach leads to the other. So it seems like it's a very Euclidean geometry problem, right? So solve using Euclidean geometry sometimes. So for some time, use tangents and similarity to solve using Euclidean geometry. Okay, any doubts and questions till this point, guys? Any doubts and questions? No, you can also do coordinate bashing. Sure, it's up to you guys. So I will give you some time to think about this problem, guys. It's a really interesting problem. We will solve it in two different manners. Any ideas, guys, till this point of time? We can say, yeah, you're right, but how to approach this problem in a different manner? See, so I have tried, I will tell you. So this problem, I will tell you the story behind this problem. So I was so this problem was given to me my school teacher, not when I was in school, but around 2-3 months back. Okay, and I tried it for one day. I couldn't solve it by Euclidean geometry. Okay, I will tell you where I failed and how it can help you out. Then I tried for the next 1 minute or 2 minutes using coordinate geometry, and it was solved in an instant. And then I reversed it using coordinate geometry, using Euclidean geometry to get the coordinate geometry solution, to get the Euclidean geometry solution. So I will show you how I did it. Till that point of time, any ideas on how to approach this problem, guys? Coordinate geometry is a good idea. Let's do it by coordinate geometry first. Let's do it by coordinate geometry. So I will show you now that how to use coordinate geometry and how to use Euclidean geometry together. What is the relationship between them? That is really, really important, guys. Okay, you must understand this. So let's do this. Let's do it by coordinate geometry. So what do you do by coordinate geometry problem? You do it by coordinate geometry problem like this, that in fact, coordinate geometry helps you give intuitions to what are the good, what are the good constructions to make, and you will understand why. Okay, you will understand just now why. So before that, let's do it by coordinate geometry. So coordinate geometry के लिए what you need to find? Let's say this is some x comma y. Okay, and this is 0 comma 0. This is 6 comma 0, right? Because the length is 6. This is 0 comma 6, and this is 6 comma 6. Okay, lovely. So what we need to find out? Can you tell me what you need to find out? What is r in terms of x and y? Can you tell me what is r in terms of x and y? See, coordinate geometry is really useful. No, we will not write equations of circles. Really, let's see what are the steps. Okay, what are the best steps to do it? So can you tell me what is r? R is what? This length is 6. This length is x, right? What is x comma y? This means this length is x. So r must be what? 6 minus x. So we need to find x actually. RTF x. We need to find x as a solution. Then we will find the 6 minus x to get the solution of this. Okay, and let's see. The best thing about coordinate geometry is, guys, this, that we can easily use all the information. We can induce all the information. So we will be understanding, okay, we have induced all the information. We have to just solve this. This is the best part of coordinate geometry. So you will be tension free. But often it turns out to be really complicated in solving the problem. Okay, so that's why we will, let's see how we can do it. So we need to find x. So there's nothing to find y. But let's see what are the information over here. The information here needed is that this circle is tangent to all of this. Okay, so we need to write the information down. Where is this circle tangent to, right? So understand that this is r. So what is the equation of this circle? So therefore understand this, that what we have over here is that we need to understand these points and we need to equate it to 0. So we know this point, we need to equate that this point, and this point are, it's like the distance is r, so that we can understand that we have used all the information. Let's write down the equation of the pink circle. Let's write down the equation of the pink circle. Pink circle की equation is what? X square plus y square is equal to 6 square. Let's write the equation of the blue circle. Blue circle की equation is x minus 6 whole square plus y square is equal to 6 square. And let's see the orange circle ka equation. The orange circle ka equation, okay, let's call it h comma k. Okay, r is equal to 6 minus h. You need to find h. So orange circle equation is x minus h square plus y minus k square is equal to what? R square. But you know R is equal to 6 minus h. So it's 6 minus h square. So we need to find h. We need to reduce, we need to remove y from the equation, okay? We need to remove y from the equation. That is our aim. All of you understood what I have written over here? Any doubts? So there are 3 equations on the circle. Any questions, guys? So what we will do next? We need to incorporate the idea, we need to incorporate the result that this 3 circles are tangent to each other. For that, what we need to do? We need to find where they meet. So let's sort of equate it. So it's like these are the points where they are equal, right? These are the points where they're equal. These points are these two. So let's try to find out where the blue meets the, like, blue and orange iska meeting point dekhte hain. Then there is orange and what? Orange and pink. And there is blue and pink. So let's understand each of this meeting point. One by one. So let's start with the easy one. Always the easy one, guys. So easy one is what? Easy one looks like pink and blue. So pink and blue is x square plus y square is equal to 6. Square is equal to x square x minus x6 whole square plus y square is equal to, so y square get cancelled, so you get x square is equal to x minus 6 whole square. So you get that, you will get that x is equal to 3 over here. X is equal to 3. And we get x is equal to 3 over here, okay? And since x is equal to 3 and x square plus y square is equal to 6 square, so you get y is equal to 6 square minus 3 square. Y square is equal to 6 square minus 3 square, that is 36 minus 9, 27. So y is equal to 3 root 2. 3 root 3, sorry. So this is x and y you got. For the pink and the blue intersection part, so let's write it down over here. So this is 3 comma 3 root 2, 3 root 3. You see, now you can easily find out the distance. If someone asks you to find out this distance, you know this is now 3 root 3 without computing everything, without doing utility. That's the power of this. That's the power of this. वेक्टर ट्रिपल प्रोडक्ट कहां पे आया है? Where is vector triple product? Anyways, so we have understood this is 3 comma 3 root 3. Now we need to understand these 2 points also. What is this point, guys? This point is really easy. This is 6 comma what? The height is what? The height is k. So this is 6 comma k. So we know this point already. And let's try to understand this point now. Let's try to find out this point. The orange and the blue. Blue and orange mein kya hoga? It will be x square x minus 6 whole square plus y square is equal to 6 square. Like minus 6 square is equal to 0. So we need to subtract x and y, okay? So we need to use these 2 equations, subtract x and y. So understand that we need to subtract x and y. We need to understand that. And what we need to find? We need to find certain things. What is? We need to find the distance from this to this and this to this. So let's try to find it out. Okay, so let's try to find out this one. That's x minus 6 whole square plus y square is 6 square. And we have blue is equal to orange is equal to x minus h whole square plus y minus k whole square is equal to 6 minus h whole square. Let's write blue and pink now. X square plus y square is equal to 6 square, and x minus h whole square plus y minus k whole square is equal to 6 minus h whole square. So let's write it down, okay? So this if we expand this, what we get x square plus y square minus twice hx minus twice ky is equal to 36 plus h square, यहाँ पर plus h square है plus k square है, minus 12h. So you cancel h square out here, so you get something, right? And you know x square plus y square equals 6, so you can delete it to be like this. So what we get over here, we get that 6 plus k square minus twice hx minus twice ky is equal to 36 minus 12h. So one equation we have got by solving these equations. Okay, and we know what? We know something over here. Okay, by the way, have I missed something? No. So this h, this x and y will only have one single equation, okay, one single solution. So can you tell me what it can be? Any ideas? How we can proceed from here? So our understanding, we are using all the information out here. Okay, we are using all the information out here. But what we need to find? We need to find h. We need to find 6 minus h rather. So how do we find that is the main question over here. So I'm so sorry. Is this okay? Yeah, I think we didn't need this blue and this pink and blue ka intersection. We need only orange ka this ka intersection. But ठीक है. This point is this. So yeah, perfect. So tell me how we can proceed this now. Any ideas now? Are you getting this point now? How we can proceed? We need to find h, right? So how we can proceed now? What do you feel? So what do we know here? We know that 6. Okay, we know that. What else we know? We also know something. What is that something? We'd use all this information out here, guys. What is this distance? What is this distance? Can you tell me? There's something interesting. Try to understand this now. This is something we mix with coordinate geometry. Try to understand. Try to now remove all these aspects, okay? Try to understand this now. What is you're trying to understand? This is what you're trying to understand. Try to join this. This is R, right? This is R also, and this is R. So the center must join with the centers, right? Where they're tangent through. This is also R. And this is what? This points is what? This is 6 minus R. Why? Because this radius is 6, so this is R, this must be 6 minus R, and this similar 6, so it's 6 plus R over here. So what do we know over here? What is this point? Can you tell me what is this point? This point is what? Can you get this point? This point is what you have got? X comma y, right? So we can find out the distance from here to here. We can find out the distance from here to here, right? How we can find it? That's the main question. So we don't need all these equations out here, okay? We can use it by a click of Euclidean idea. Perfect. All are R. So how we can do it? Let's rub all of this out. These are not actually required. So the idea is that in coordinate geometry also, you have to use a bit of Euclidean geometry also. It's a mixture of that to get the best solution out there. So we want to find this. So we have R over here. Understand this. So this is 0, 0. This is x, y. And we know this point is 6, 0. This is what? 6 minus R. This is 6. What we know? Sorry, this is 6 plus r. I'm sorry. And this is what? This is 6. And this length is r. We know that. And this length is 6 minus r. We know that. So this is 6 minus r, comma y. So how we can find this out, guys? Let's try to understand this. So we can find out this, we can find out this, we can both equate to this, and we can get the y out. How we can get the y out? Understand this. 6 minus r square plus y square is equal to 6 plus r square by this distance formula. And from this distance formula, what we get? That 6 minus r minus 6, that is r square plus y square is equal to 6 minus r whole square. So we have got this, right? So we can replace this over here. We can replace this y over here. So what is y over here? So we get that 6 minus r whole square plus y is equal to 6 minus r whole square minus r square is equal to 6 plus r whole square. So what do we get? We get a coordinate, quadratic in r, right? We get a quadratic in r. You understand? You get a quadratic in r. Now solve it, guys. So if you just solve it, 36 plus r square. So now let's not solve it in a very, so 36 plus r square minus 36 minus 12r minus r square. Now you know a plus b whole square minus a minus b whole square is what? It's 4ab. So it's like 24r. So you get from here that r square you deleted. So you get that 36r is equal to 36. So r must be equal to 1. How beautiful it's done, right? So it's actually a mixture. You see, you started with coordinate geometry, but you ended up mixing it up. So it's a mixture of all this. So the best solution, now how to convert an Euclidean geometry, it's very simple. You draw a perpendicular over here. Now you use the Pythagoras theorem, because whatever I use is actually the distance formula is just Pythagoras theorem. If you want to use just normal geometry, Euclidean geometry problem. Okay? This is the idea. The Euclidean geometry, the coordinate geometry approach give you an idea about the Euclidean geometry approach. These are interrelated to each other, right, guys? This is the beauty of this idea. You need to know everything so that, yeah. So all of you understand the solution, guys? Yeah, purely with synthetic geo. How we do it? We just expand this, na? We just expand this equation. So what we do it? I will show you. We do it using this. I will show you the thing I've written in my copy. This is how we do it. If you just, I don't know if you can see or not. Can you see it? So we can just draw perpendiculars over here to get the solution, because that demands the entire thing. That demands the entire thing. All of you understood this idea, guys? So I didn't use coordinate geometry, Ramakrishna, over here. I just use directly, you see, coordinate geometry, normal geometry over here. No coordinate geometry, just Euclidean geometry. See, in this solution I have given in the picture, I just draw perpendiculars. So if you want to understand the constructions are important. So the constructions actually are motivated by this coordinate geometry approach. Maybe you want to do it just by Euclidean geometry. So this is a very good example how they're interacting with each other. Okay, this is a really good example. So you must follow this, guys. It's really, really important to have a sound knowledge of this. Very good. So this is a connection, guys. This is a connection between synthetic geometry and Euclidean coordinate geometry. They're actually equivalent to each other. If you understand, if you do all the proofs of Euclidean geometry in synthetic coordinate geometry, they're all using Euclidean geometry. So they're actually equal. Same sides of the, different sides of the same coin. Okay, guys, it was really nice talking to you. And if you have enjoyed, just post a comment, enjoyed. And we'll again meet in the next session, where we will understand about another preparation idea about number theory or combinatorics or algebra. Let's see which one. Okay. So post a comment enjoyed if you have enjoyed the session, and I will see in the next session. Stay tuned, and if you like this, don't forget to like and subscribe. Okay, and share it with your math friends. All the best, guys, and see you in the next live session. Stay tuned and stay blessed. Thank you, Abhiram, for enjoying session. Thank you so much.